Okay, Carla is there. So, nuts. That means, oh wait, no, that's Liana. No? That's Liana. No. I hate names. Why do they have to exist? When you sign up, you should just be assigned a number. Student 1, student 2, student 3. Great. So who are we missing? We're missing Liana. That's what's throwing me off. Okay. Trying to pin that on somebody. So you're Esmeralda then? No. Why are you not Esmeralda? Are you sure? Dang it. So bad at it. Oh, Alondra. Did this every time. Okay, that's Alondra. All right. I need to make flashcards. That's the problem. See, I did that last year, and I didn't do that this year because everything's online, and it was just, it's a mess. Anyways, good afternoon, everybody. We're going to have some fun today. We're going to go outside and measure stuff. Okay? Not just yet. Hang on. Hold your horses. Not right away. Okay? We got to talk about what it is we're measuring and how we're going to do it. All right? So this is our objective. We want to find the height of the flagpole. Okay? So we're going to send Mark up to the top with the end of the, no, I'm just kidding. Right. That's the thing we can't do. We can't really climb up the flagpole very easily. The school ladders, I don't think, are even tall enough to reach that far, so we've got to find an indirect method. Luckily, we have some geometric tools to help us. Right? I think you would all agree that the thing we can measure very easily would be along the ground. We could get the horizontal distance from you to the flagpole, right? That's easy enough. I've got a tape measure here. We can do that one. Agreed? Okay, we can do that. And if we knew how tall you were, right? And you'd be about, there. So we'll call that height T. Really, all we need to know is how much taller the flagpole is than you, and we could just add those together to get the total height, right? That would be easy enough to do, simple addition. It's just a question of how do we get this bit? How do we know how much taller the flagpole is from you? Well, from you, you can look up at the flagpole, and you can see the tippy top. And compared to straight across, right, this measurement x, you can look at that angle there, which I'll call alpha. And guess what? The flagpole is perpendicular to the ground, right? And this, straight across from here, we'll say that's parallel to the ground. So those are all 90-degree angles there. So we can create a right triangle here. And we can measure this, and we can measure that. And thanks to our friends, the special right triangles, we can quickly and easily calculate y, the extra height of the flagpole above you. Do you guys see how we do that? Not immediately. It's not obvious yet. Let's make it obvious. How are we going to do that? Well, what if alpha is, let's start with the easiest possible case, 45 degrees. Okay? Fill 45 degrees into that triangle. Then I would get what kind of triangle? It's a right triangle for sure. What kind of right triangle? If this is 45 degrees, what's the other angle? 45 degrees. What do we call this special right triangle? 45, 45, 90. Yeah, mathematicians are so lazy when it comes to names, right? And what's special about this right triangle? we know all the relationships about the sides. We know how they all compare to each other, right? So if I told you that this is 10 feet here, what do you know about the other two sides? All three of them? It's an equilateral? No, not all three. How many? Is one of them the same? Yeah? Which one? That one, the vertical one. Yeah. The one on the left, one up and down, right? Because notice this 10 feet is across from the 45-degree angle. So this side also across from 45-degree angle. If it's across from the same angle, then it must be the same length. Because this is an isosceles triangle, not equilateral, isosceles, right? Two sides the same, across from the two base angles that are the same. If you really want to know, for completeness sake, the hypotenuse is 10 times what? Anyone remember? It's one of those funky irrational numbers, the square root of 2, right? Which has, infinitely progressing decimal. So, if I can guarantee that the angle I'm looking at the flagpole is a 45-degree angle, then the height of the flagpole is the same as the distance I'm standing from it, plus my own height, right? Everybody agree on that? Any questions on that triangle? How we can use that to do this? Now, that's not always an option, right? We got to force it to be 45 in order to get that super easy result, right? That's the simplest calculation ever, the same number, right? We don't have to do anything to it. You can't always get 45, but there's the other special right triangle. What if alpha was 60 degrees? Because notice here, if the height is the same as my distance from it, that means in order to measure something, I need to be able to stand a distance from it that's as tall as it is, right? I don't always have that much space. If we want to measure something really big, then we got to stand really far away. If I want to measure the tree in my backyard, the tree could be taller than my yard is wide. What do we do then? Well, now I need a different triangle. So here's where you might be able to use a 30, 60, 90 triangle. Still 90 there, 60 degrees here, 30 degrees up there. And now if this is 10 feet in the horizontal direction, this is across from my 30-degree angle, so this is the smallest measurement of my special right triangle. The largest measurement is always where? Where's the longest side of a triangle? Hypotenuse, yeah, right here. That side is going to be twice the shortest side. So in this case, 20 feet. Which means the third side, the missing one, the height across from the 60-degree angle, is the odd one out. It's got to be 10 times something more than 1 but less than 2. Anybody know what number goes there? .5 would be nice, right? Or 1.5? It's not 1.5. It's another irrational guy again. In this time, it's square root of 3. Right? You should have these special right triangles in your notes, right? So you can look them up and compare. Right? Which means if you can't fit the 45, 90 triangle in your space, in your physical measurement, maybe you can fit a smaller distance and use a 60-degree angle and use this special right triangle. Then all you have to do with that horizontal measurement is multiply by the square root of 3. Okay? So it's one extra step. Now, We have the luxury of plenty of space out in the parking lot. So which triangle would you rather use? Any votes? Any thoughts? The 45, yeah. So we're going to take advantage of that. You guys at home, I'm so sorry. You don't get to join us outside measuring the height of the flagpole, but you got to measure something at home. If you're something at home, you can't find something where you can fit the space in, you can use that other triangle. You have one extra step you have to do. That's it. Now, how do we actually find that angle? How do we set it to be 45 or 60 degrees? How can we guarantee that? The answer is this. We're going to use this simple tool, handmade, that you guys can create at home. I have gone ahead and constructed it for us, just so we didn't have to spend class time crafting. We can go spend class time measuring, but it's very easy. The full instructions are there on the link on the classroom post. It's a WikiHow, okay? It's a piece of paper. In this case, I bought some binder, like tab dividers, so it's a little bit thicker of a cardstock paper, so it holds up. You fold a square in half along the diagonal. And now what shape do you get? 45, 45, 90 triangle. And cut this guy in half, and you get two 45, 45, 90 triangles. That's that symmetry at work there. It's beautiful. So now I've got a nice, small, manageable size. You tape a drinking straw to one end, or to the hypotenuse. Okay? Tape a piece of string to one corner, and put some kind of weight on the string. I used binder clips because that's what they had at the Dollar Tree. Okay, you could, if you have a washer, it's the classic dangling weight you can tie onto there. So it hangs here. And now what you do is you take this thing, you look through the straw at whatever you want, okay? Whatever you want. And this dangles out here, and it tells you the angle you've raised this at. If I look at something further up, notice as I tilt this up, the string comes down, 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 right? See that? So if I'm looking through the straw at the thing I want to measure, the height of that, try to hold this so you guys can see what's going on here. Okay? I'm going to look up there and say, oh, it's that tall. My string is here. I want it to land there because this is a perfect 45, 45, 90 triangle. If I could set this so that this side is flat and parallel to the ground, then this side is perfectly perpendicular, straight up and down. And the string hangs plumb to that, right? Here it's not plumb. Here it's not plumb. I want the string to hang parallel to this edge. On these ones that I made a little black mark to make it easier to view when we're outside, so you can see that, yes, the string is hanging parallel to the vertical side. When you have this tilted such that the string hangs right there at that black mark, you're holding it at a 45-degree angle. So anything you look through the straw at that angle is a 45-degree trajectory to the top. Does this make sense, how this works? This is called a clinometer because it measures incline, an inclinometer, right? Clinometer. What you're going to do is you're going to go outside to the flagpole. Near the flagpole. You're going to pick a spot. You're going to stand here. You're going to look through the straw at the flagpole. You're going to say, where's the string land? Oh, too far. I got to get closer. So I go further up. Okay, look through to the top of the flagpole. Where's the string land? Up, too steep. Further back, right? And so you're going to adjust your position back and forth until you find the spot where you can look through the straw at the top of the flagpole and the string lands right on the black mark. Is that clear? That is your main objective. Once you have done that, you have your spot. We now need to measure the distance from you to the flagpole, and we're done. That's your measurement. Now, if we will also need your height eventually, we'll take care of that when we come back inside, right? When you have that spot, you flag me down, say, hey, and then you'll take one end of the tape measure, and I'll go to the other end, and we can measure how far you are from the pole. Make sense? Any remaining questions on how that process is going to work? Okay. You will then need 2 or 3 things. 1, a clinometer. There's enough. Everybody has one. Okay. Second thing, some way to record your measurement. Okay, so if that means take paper and pencil, you can write it down. Or if you have a note-taking app in your phone, you can just take your phone and enter it there. And then it's a bit windy out, that way your pages aren't flopping in the wind. Anyway, up to you. Okay? Any remaining questions before we go? Is that a hand? No, just stretching? Okay. All right, you guys at home, you're on your own. We'll see you later. Submit your final answer on Classroom.